Hello, everybody. The topic of today is the metric system or the international system of units. We are going to study the different systems of units, but our main focus will be the international system of unit, otherwise called the metric system. By the end of today, you should be able to define what a physical quantity is and state the different types of physical quantities. You should be able to define the metric system of units as well as give its prefixes. And thirdly, and most importantly, you should be able to convert from one unit system to another. And we are going to do this using the conversion factor method. Now, what really is a physical quantity? Physics is a quantitative science because it deals with things that can be measured. Anything which can be measured is quantifiable. In other words, anything that can be measured is quantifiable. Anything that can be measured is quantifiable. And anything that can be measured is a physical quantity. Therefore, a physical quantity is any attribute of nature that can be measured. Anything that can be measured is a physical quantity. Is a physical quantity. Anything that can be measured is a physical quantity. Now, to measure any physical quantity requires a standard of measurement. Let me put it this way. Measurement essentially is an act of comparison. Comparing one physical quantity to another. Now, for measurement to make sense, one of the objects being compared must be known, and that object is known as the unit. In other words, for measurements to make sense, you must be able to identify the unit of measurement. A unit basically is a measure of a physical quantity. Let me put it this way. A unit will help you to identify what is being measured. And without a standard of measurements, the measurements will not even make sense. So it is important for you to realize that one, a physical quantity is anything that can be measured. Examples include length. Examples include length, area, force, velocity, acceleration, and so on and so forth. Any attribute of nature that can be measured is a physical quantity. Any attribute of nature that can be measured is a physical quantity. And to measure requires a standard of measurement. And that standard of measurement must precisely be defined. And we call that a unit. There are basically two types of physical quantities. You have fundamental physical quantities, and you have derived physical quantities. Fundamental physical quantities and derived physical quantities. A fundamental physical quantity is any quantity that can be measured directly. For example, the length of a book. If you want to measure the length of a book, All you have to do is take a ruler and measure the length. You don't need to measure any other thing. So length is an example of a fundamental physical quantity. As a matter of fact, there are 7 fundamental physical quantities. You have length, you have mass, you have time, you have the amount of substance. You've met this in chemistry. You have electric current, you have temperature, and you have luminous intensity. So there are 7 base quantities: length, mass, time, amount of substance, electric current, temperature, and luminous intensity. What this means is that there are 7 base units. There are 7 base units. Now, in the metric system, also known as the international system, there are 7 base physical quantities. You have length, measured in meters. You have mass, measured in kilograms. You have time, measured in seconds. There's a little mistake here. Seconds. You have temperature measured in kelvins. You have current electricity measured in amperes. It's a French word. And you have the amount of substance actually measured in moles. Luminous intensity, you will hardly meet this guy, measured in candela. It is critical for you to be able to recognize these 7 fundamental quantities. As a matter of fact, mechanics relies on the first 3: length, mass, and time. Everything that you will see in mechanics will be expressed in terms of length, mass, and time. Later on in the semester, we will add electric current. We will add electric current, the amperes. And every other thing that you will see will be expressed in terms of length, mass, time, and electric current, or the amperes. Length is measured in meters. Mass is measured in kilograms. Time is measured in seconds. Electricity is measured in amperes, symbolized by the capital letter. Now, that being said, there are 7 base units. Any other unit is a derived unit. Why derived? Because the unit of that physical quantity is derived in terms of base unit. Take, for example, velocity. Velocity is defined as displacement divided by time. Therefore, the unit of velocity is simply meters divided by seconds, which can be rewritten as meters s raised to the power 1. So the velocity is a derived quantity, and meters per second is a derived quantity. Another typical example is force, which is mass times acceleration. This means that the unit of force is the unit of mass multiplied by the unit of acceleration, which is meters per second squared. So this is kg m per second squared. So these are the units of force, which happens to be 1 Newton. Now, sometimes it is critical for you to realize that a given physical quantity can be measured in more than 1 unit. Take, for example, length. The SI unit is the meters. It can be measured in centimeters, in nanometers, in picometers, in kilometers, in miles, etc., etc. So a given physical quantity can have more than 1 unit. Now the question is, every physical quantity has an SI unit, and in this course, you will have to endeavor to express every physical quantity that you will meet in SI units. But the unit used depends on the context. For example, if you want to measure the length of a cell and you express your answers in terms of meters, it will not make sense because the cell is so small, and that is why it is expressed in terms of either millimeters or in terms of nanometers. If you want to measure the distance from the moon to the sun, it is best expressed in terms of either miles or kilometers because the distance is so vast. Now, when you want to write very large units or very small units, it is critical for us to use prefixes. Take, for example, you want to write, let me say, 1 million meters. 1 million meters. My goodness, isn't it really? It occupies a lot of space. This is actually summarized 1 million meters stands for megameters. Or let me say you want to write 0.000000001 meters. Isn't it just simple if you put it as 1 nanometers? Which one is preferable? 0.000000001 meters or just 1 nanometers. It's a no-brainer. Personally, I prefer 1 nanometers. Now, it is, take for example, if the height of a house is given in terms of inches, let me say it's 55. Let's say the height of something is 55 kilometers, the height of a mountain, and you're asked to express this in terms of millimeters. How do you move from kilometers to millimeters? We will use the conversion factor method. Now the method is simple. You start with the unit given. Listen attentively. You start with the unit given and you end with the desired unit. Now, in the denominator, you put 1. In the denominator here, you will put 1 kilometers. 1 kilometer is equivalent to 1,000 meters. This is 1 meters. Now, 1 meter, how many meters? If you look at this table, this is millimeters. It means that 1 meter is 10 to the minus 3. So 1 meter is equivalent to 1,000 millimeters. So you realize that the kilometers will take care of each other, the meters will take care of each other, and your solution will be 55 multiplied by 1,000 multiplied by 1,000 millimeters, which is equal to 55 times 10 raised to the power 6 millimeters, which will be equal to 5.5 times 10 raised to the power, this is 6, 7 millimeters. And this is our solution. Let's say John is measuring 2 line segments. The first line segment is 40 centimeters. And the second line segment is 800 millimeters. And how long are these 2 line segments? Now understand that you can only add 2 things with the same units. So, in order to add L1 and L2, you would either have to convert 40 centimeters to millimeters or 800 millimeters to centimeters. And to do that, we use the conversion factor method. So we have 40 centimeters. This is 1. This is 1 centimeters to 1 centimeter is equivalent to how many meters? To 10 raised to the power minus 2 meters. 1 meter is equivalent to 1,000 millimeters. So if you add all of this or multiply all of this, this would mean that you have 40, because this takes care of this, this takes care of this. You will have 40 multiplied by 10 millimeters, which basically is 400 millimeters. Hence, our solution would be 800 millimeters plus 400 millimeters, which is just gonna be 1,200 millimeters if you add the 2 lengths together. Thank you so much for watching this video. I hope you learned something. Our next video is gonna be on dimensional analysis, and it's very important in the field of physics for you to understand dimensional analysis, because it will give you the tool set in order to manipulate and know if what you are doing is correct. Thank you and have a blessed day.